Welcome. NOAA has just released its February of 2024 climate update and the winter of 23-24, that's from December of 2023 to February of 2024 climate update. And this video is a summary of those. Normally when you get a winter video, you expect what you see here, snow. However, this last February has been more like this. It's the hottest February on record. Let's have a quick summary of what we're going to talk about today. I'm going to talk about why February was the hottest on record, and also the hottest winter season on record since 1850. That's the limit of where the modern day record goes back to. Both land and ocean set new highs. Both hemispheres set new highs. This was the same not only for the surface temperature, which is what I'm talking about before, as for the upper atmosphere. Global sea ice extent is the fourth smallest extent on record. El Nino is still going, although ENSO neutral conditions are expected in the next 3 months. Atmospheric carbon dioxide levels reached a new high as well. So this is not a very rosy picture for the Earth's climate. Let's take a look on how these temperatures were distributed around the globe. Both North and South America had their hottest February on record, and winter for that matter. Europe's second hottest, Africa's second hottest, Asia the 10th hottest, and Oceania the third hottest. The Arctic was the third hottest on record, and the Antarctic, interestingly enough, was the 11th coolest, bucking the trend. The world's oceans, both North and Southern Hemisphere, were the hottest they've ever been recorded. Here's a plot from NOAA on the global temperature average. And you can see that February beat previous records, which was in 2016, by a full 0.1 degrees centigrade. In global terms, that's a very large number. We can see that there's been a steady rise in global temperatures since the 1970s, and that trend is continuing, if not accelerating. A very similar picture for the meteorological winter, that's, as I said, December through February, and the two set a new all-time record, beating out 2016 by over 0.1 degrees centigrade. Here we are looking at a temperature distribution map, but on a much finer spatial scale than before. This is what is called a percentiles map. It breaks up each part of the Earth into a ranking. Deep blue is a record cold. Deep red, which is a lot of on this map, is record warmest. And then you have much cooler than average, near average, which is the white, warmer than average, which is pink, and much warmer than average, which is the light red. You can see that there is a finger of warm water stretching from the west coast of South America out into the Pacific Ocean. That is the El Nino. We have a swath of record temperatures stretching from Western Europe all the way down into South America, some parts of Africa, the Indian Ocean, and Oceania. The only place that is colder than average is the Antarctic. You can see there's some major areas of blue down there, which is much cooler than average, though no records. Now let's take a look at the map over the period from December to February, a meteorological winter. It's a very similar picture to the previous one, with the exception of Antarctica, which is basically all blue. So most of the world had above average temperatures except for Antarctica, and the penguins were probably not very happy about this. We even had some record cold temperatures in the Antarctic, which is really saying something. Well, let's take a look at global temperature trends. The rankings globally, it was the hottest February on record, as I said. Land was the second hottest, ocean was the hottest. The Northern Hemisphere, hottest February. Again, second warmest was the land, and the ocean was the warmest. Southern Hemisphere, exactly the same thing. Land second hottest, ocean hottest. And this all sums together to make February the hottest February on record. Well, that was surface temperatures. How is the rest of the atmosphere doing? This is data from the University of Alabama in Huntsville, showing the temperature for the above about 4 kilometers in the atmosphere. So it's not, the surface temperatures are quite a different thing. As you can see, the overall trend has been upwards, in contrary to what a lot of people claim. But the last month was the hottest month ever recorded in the upper atmosphere. You can see the little purple spot there. So that's a new record. And then if you take the 13-month running average, which is here, the red curve, that also sets a record all time since 1979. A lot of people pay attention to sea ice. I'm not quite sure why. I don't think it's that important, but let's show it for completeness anyway. The northern hemisphere sea ice, which is basically the Arctic, shows its continuing decline. It was the 15th lowest on record out of 46 such measurements. So it's in the top 1/3 of low signals, although recently the sea ice there has been relatively flat. The Antarctic sea ice shows a similar story, except for the fact that it's been dropping for about the last decade, and this was the second lowest on record of, again, 46. The overall trend has turned negative to 0.06 million square kilometers dropped per year. When you add these two together, you get the global sea ice picture, and it's shown here. And it was the fourth lowest overall global sea ice on record, because that's really dominated by the Arctic. Antarctic numbers are relatively small. It seems that El Nino is weakening. If you look at the tongue of hot water off the west coast of South America, you can see it looks as though it's beginning to break up and get smaller than it has been showing for the last few months. But we can estimate what will happen from the various models of El Nino and La Nina, and that is shown here. This is a probability plot of the relative chance of El Nino, La Nina, and then some neutral conditions. When we have an El Nino, those red bars are higher, and so we should have El Nino probably through to the middle of April. From then until June, we should have ENSO neutral conditions, so neither El Nino nor La Nina. And then in June onwards, we should be getting La Nina conditions. And that's not a good situation for the Atlantic hurricane season. So be warned, it might be an active season. Each month I show the level of carbon dioxide in the atmosphere measured by the NOAA observatories. In February, the number reached 424.55 parts per million. That's the highest ever recorded in the modern era. In fact, probably going back about 3 million years. And that's an increase of 4.5 parts per million over the same time last year, which is a very large increase. This has normally been around about 2 for the last few months. Well, do we have any hope that the sun is going to help moderate this? And at the moment the answer is no. This is the total solar radiance, i.e. the amount of energy the Earth receives from the sun. And the orange curve here is the last solar cycle 24. The red curve is the current one. And you can see it's gone way up over the last 4 years and still seems to be rising. So we're not moving into solar minimum as yet. So what conclusions can we draw from all of this? Well, El Nino looks as though it's going to continue at least until April of 2024, followed by a short period of ENSO neutral conditions, and then we would plunge into a La Nina. Global temperatures are continuing to rise. That's not unexpected. And this year could make 2024 the warmest year on record, even hotter than 2023. It's certainly starting out that way. The sun is still approaching solar maximum, and so we'll get more energy input from the sun, although it's actually a marginally small amount. So thank you for watching, and until next time, stay safe and goodbye.